Today we are going to look into the gas distribution optimization in blast furnace, where we will see that what should be the balance of wall and central flow. As we discuss with the blast furnace operator, and most of the time, most of them are having a lot of inclination on central working furnace, but at the same time we forget to balance the central flow with the wall flow. So we need to look into whether this central flow is it excessive, whether the wall flow is okay. With respect to wall and central flow, it is optimum setup, and with this optimum setup, whether the productivity is satisfactory. Further, we can also see what sort of stability of ETA-CO exists in the furnace. Now coming to the next slide, which is about our concern that if we prefer more on a central working, then our expected CO utilization drop. There is more chances of tuyere failures, and further it will also reduce the furnace life, because on the bosh reason we started handling more heat load. Now coming to see that two cases when we have a less central flow and we have a more central flow, we can see with the too high central flow our ETA-CO went down, and many time operator could able to visualize in the top camera that axial flow is uh, much severe, which can be visualized with the axial concentration of the light in the amanoscope central region. At the same time, this will corroborated. This can be correlated with the fall in CO or something much inferior CO, and occasionally such band arises at around 41-42 level. And as I mentioned, there will be a wider center, and that means whatever ideal is around 1 to 1.5 meter axial opening, it goes beyond 2 and more than that, where utilization drop because the outgoing gases could not able to retain, and utilization drop. And these also result in low position of root of cohesive on the above the tuyere region. Here in this slide, once our axial flow very high, the cohesive zone comes down, and once cohesive uh, is comes down, it is very near to tuyere, and then we have all chances of damaging chances of tuyeres. So we can say that excessive uh, excessive exposure to the tuyere as heat load bearing potential capacity goes beyond the tuyere potential, and this cause many times failure of tuyeres, and there is a sharp iron attack also there, and localized high production rate is also there. So this result into a here in this slide it has been shown that once axial flow goes much higher, our wall flow becomes hindering, which result into lower cohesive zone, and these lower cohesive zone many times result into a short circuiting because raceway gases once cohesive zones comes down could not able to penetrate to the all strata of cohesive zone, and nearby they just shot up, which we are saying a short circuiting, and this cause a lot of a spike in the bosh region, to your body temperatures, that is stable body temperatures or coolest body temperatures. So these this is happening because here reduction of proper gases is not there sufficient, and that result into a more direct reduction, cooling the furnace, bringing down the cohesive zone to be very nearer area, and finally gas shortcut. So we can say that all this brings a bad thing to the furnace and furnace operation. Hence, in the last, I will say, let us respond before the damage occur. And in these cases, someone must have to analyze closely that with respect to utilization, your balance of center working and peripheral working is exists or not. Thank you.